gentlemen, we are moving into the topic of solutions. We're introducing ourselves to it today, okay? Now, solutions are homogeneous mixtures by definition, okay? So we got to write that down someplace. A solution is a homogeneous, okay, mixture. Now, we agreed from before, right, early in Chemistry 1, homogeneous means what? Uniform, okay, composition, or evenly, okay, distributed. Okay, so when you have the solute and solvent and they're mixed together, okay, they'll be evenly distributed, a nice uniform composition. Now the question is, right, what's a solute, what's a solvent, okay? Now the solute is simply the substance that gets dissolved, okay? And the solvent, by default, is a substance that does the dissolving, okay? Now, funny thing, guys, we think of solutions, we automatically think of, it has to be a liquid solvent, right? But you can have solutions like, for example, air. Air is a gas solution, has many different gases in it, right? But they're mixed in a homogeneous way because each one of them has a specific ratio, a specific percentage, okay, in there, no problem. Also, you can have a solid solution. It sounds kind of strange, but brass typically is considered to be a solid solution because the two metals that make it up are mixed in a uniform way, uniform composition, so no problem, okay? So just keep that in mind. But typically, right, the most solutions that we find in our daily lives are, have liquid solvents, but no problem. Just keep in mind that it doesn't have to be always that way. Okay, so let's look at some things, right, that can affect solubility. Now, what is solubility? All right, solubility. It's simply the amount, right, of solute, okay, that dissolves, okay, at a specific temperature, all right? Now, it dissolves at a specific temperature in a given amount of solvent, okay? So that helps you figure out what solubility is. Some things have low solubility, some things have very high solubility. And there's some factors, right, guys, that affect that, okay? So we're trying to look at some of those factors, okay? Now, let's see. One main factor that affects it is nature of the solvent. Okay, we discussed this in class, right? And we had this rule that we talked about, and we said like dissolves like. All right? And what does that mean? Okay? Polar substances, right? If you know a substance is polar molecule, it will dissolve other things that are polar. Now here we go again, right? I keep saying chemistry is foundational. You have to know, guys, from the SNAP rule, SNAP, right, that we did before, okay, whether a molecule is polar or not, because you can be asked, right, will these two substances dissolve in each other, okay? So you have to know whether the molecule is asymmetrical and polar or symmetrical and non-polar, okay? This is very, very, very important. So, polar substances dissolve other polar substances well. On the flip side of that, non-polar substances dissolve other non-polar substances well, okay? So non-polar to non-polar and polar to polar, all right? That's essentially like dissolves like right there. But we're going to put one more thing down, folks, all right? Polar substances, all right? P-O-L-A-R, it's called polar, dissolve ionic things though, all right? Now we're assuming, right, that the ionic is a normal ionic substance that's soluble. Polar substances, like for example, the classic polar substance, universal solvent, water, dissolves, for example, table salt very, very well, no problem, okay? It rips it apart, pulls it apart due to attraction in a process called molecule ion attraction, okay? No problem. All right, so this is one factor, okay, that affects solubility. Now, guess what the other factor is? Okay, if you said good old temperature, correct. All right, so temperature, okay, affects solubility, definitely. So for example, let's say you're trying to make tea, right? You're not going to freeze the material, are you? Okay, preferably, you have the water warm. Okay, so most solid substances and liquid substances, when you dissolve in them, you want the temperature to be, reasonable. Yes, reasonable temperature, so you can have the solid solvent interacting and get your material dissolving. Okay, now, so we got to make a distinction though. You have solid and liquid, okay, solids, right? But you got to be careful in relation to gas solids, all right? Now I tell everyone, think of what? Think of a soda can. Think of soda. And you drink the soda, right? Can of soda halfway. Where do you put it? You put it in the oven, you put it in the fridge. Typically, right, most people will put it in the fridge, right? Because the thing is, for gases, right, as the temperature increases, if you increase the temperature on the soda can, for example, and it's open, you put it like say you put it near an oven or on top of a stove or something, and it's warm, okay, the solubility will decrease. Okay, this is for what? This is for gas solids, all right? So it's kind of the opposite for solid and liquid solids, right? You increase the temperature, it's not good. The carbonation the fizz will escape. It'll taste flat, right? No problem. Also, pressure, number 3, is another factor that we're going to look at, all right? Pressure. Now, the funny thing, guys, pressure does not really affect solid and liquid solids, right? We mainly focus on gas solids. I'm going to write that down someplace. Gas solids, okay? Bam, whoops. Now, let's analyze it. You have your soda company, all right? You want these gas particles to go into the solution, right? Well, the question is, let's say you have this movable cover right here, okay, and you can move it up or down, all right? You can move this guy up or down. What are you going to do? Are you going to release pressure, or are you going to increase pressure, okay? Hopefully you figured out that you're going to increase pressure to do what? To force these gas solid particles into solution, right? Okay, so increase pressure. When pressure goes up, alrighty, guess what happens? Okay, the solubility of gas solids, okay, so we're going to make a distinction there, also goes up. So pressure and solubility for gases have a direct relationship. Temperature and solubility have an inverse relationship, okay? So one of the 3 main factors that affect solubility, once again, is nature of the solvent, all right? If it's polar or non-polar, okay, so you got to, remember your snap rule. Got to know temperature, okay? Temperature is pretty much straightforward, but you got to be careful when you're dealing with what? When you're dealing with gas solids, okay? I saw this memory device someplace, and I'll give it to you. I saw for gases, right? Lot hip. Okay? What does lot hip mean? So you guys like it or not? Low temperature, low L-O-T, low temperature, high pressure, okay? For gas solubilities. If you want your gas to be nice and soluble in your solution, you want low temperature, high pressure. All right, guys. As always, hard work plus sacrifice equals success. Make sure you just continue studying solutions. We'll do some actual calculations later on. But solutions are a nice, easy topic. But you gotta make sure you know your definitions, people. All right, take care.